Good afternoon, everyone. Thank you for joining us today. We are here to present the current progress of the GSI Schedule Planner, our AI-powered decision support system designed for task prioritization and intelligent scheduling for professionals. So as of week 4, we have successfully completed the discovery and planning phase and are actively working on the design and foundation phase. We are following a 16-week iterative development plan and we are currently on track. In the discovery phase, we refined the requirements, created user stories, designed the high-level architecture, and established our technology stack using React, TypeScript, Tailwind CSS, and Supabase as the backend. One small adjustment we made to the original plan was to prioritize the development of the AHP prioritization engine earlier. This allows us to test the core intelligence of the system sooner. Looking ahead, we plan to complete the design phase by July 19 and begin full core development in iteration 1. We remain confident in delivering a robust system by the end of the semester. I will now pass it over to Mr. Garnica, who will discuss our design and front-end progress.
Dangal greetings everyone. I am Raymar Garnica, the lead architect and front-end developer of the GSI Schedule Planner. Today, I will quickly show the current state of the design foundation work using the actual working system. As a lead architecture, I am responsible for the system architecture and overall user interface, and the core application shell, which are the layout, navigations, and calendar. This phase is still in progress, but the foundation is already solid and functional. So what is already working in our system? First is the full authentication, which includes the login, sign up, and password recovery. We have also responsive layout with sidebar navigations, dashboard with overview cards, task and project management, calendar interface, which are day or week structure, which these are ready to receive AI schedules. We have also the supporting pages already reachable by smart suggestions, priorities, tasks or focus mode, algorithm insights, and settings. So the architecture is also in place by React plus TypeScript front and connect to Supabase, which includes the authentication, database, and edge functions for the three algorithms, which are AHP, CSP, and PSO. Let me show the actual application briefly. Here is the login page where user can sign in and sign up. By signing in, the user will be landed on the dashboard of the system where users can see the summary of the system. We have also included the notifications, and this is the sidebar that gives access to the all major modules of the system. Here is the task based on the projects and the standalone task. This is the projects where users can organize their tasks based on the projects and can view their completion rate, as well as the add task where users can manually input the details of individual tasks, as well as the calendar workspace where users can view the dates, the time based on the projects, the schedules. Right here, you can see the quick filters, the unschedules by day, priority, deadline risk, and focus. Right here, you can see the auto schedule of the system, which automatically scheduled by the CSP. And for the referential overview, uh, the AI can rank the priorities based on their basis, as well as the today, this week, and completed tasks. In these intelligent modules, we can see the smart suggestions, the adaptive scheduling, the focus mode, the deadline risk detector, the productivity insights. We can monitor your productivity based on the analytic, based on the algorithm, the PSO algorithm. Hindi pala. Product. Here you can view the productivity insights when you can monitor the productivity rates or the patterns based on the days. And the settings, you can see the profile where users can view their inputted data, as well as the general, the dark mode of the system, and the help or about. These are not designs. This is the current working prototype. Compared to the original project plan, the core layout, navigation, calendar, and the task management are already implemented and slightly ahead of schedule. We adjusted by building a real navigable system early instead of staying longer in the design phase. The main challenge was keeping the interface clean while supporting many modules. We solved by strictly using consistent component library. The remaining work focused on integration, which are connecting the calendar and smart suggestion to the live AHP, CSP endpoints, and adding visual AI feedback and polishing responsiveness. We are on track to complete the design and foundation phase and move fully into AI integration. In short, the AI front end foundation is ready. We are now refining a working system, not starting from wireframes.
Dangal greetings, my name is Lord Inot, and my role is backend and AI specialist. On the backend side, we made significant progress in creating the foundation of our system. And the key achievements include the design and implemented the SUPA-based database schema with the proper security policies, successfully set up user authentication and the profile management, and completed core task and project management modules, and developed the initial version of analytical hierarchy process for intelligent task prioritization. And we also began integrating the basic prioritization task logic that considers urgency, difficulty, and other factors. One of the technical challenges we faced was ensuring the AHP calculation was run efficiently, and we addressed this by optimizing the scoring algorithms and implementing proper data handling. And on the back end, we have the SUPA base that we use for our back end, and this is the SUPA base table schema. And next is for the security. Next is the edge function, the ranking of tasks, the EHP, task prioritization, and this is the code. And here is the live demonstration of the current task management prioritization feature. First is we're going to create a task. Say for example, an assignment task. Then if it's a standalone task, you don't have to put it in the project. So you have to click the no project, then the category, the date, the due date, the start date, and the start time. And after that, click this analyze with AI. And this is how the AI prioritization works. We have the duration, the difficulty, the category, and the urgency or the prioritization. Then create task. Then after creating the task, it will automatically be added in the task list. So we have this, the assignment, and to see if the EHP works, we're going to the referential and overview, the priorities, and click the rank with AHP, and it will give you the updated list of what is the prioritized task or what you should do first. And this is how the AHP prioritization works. And this gives us a strong foundation to build the CSP scheduling and PSO learning features in the next iterations. Thank you.
Thank you, team. To summarize, we have successfully completed discovery and planning, design and foundation is in progress with good momentum, and core development is ready to begin. We encountered some integration challenges but addressed them through modular design and early prototyping. We are on schedule and excited about the remaining phases. Our next major milestone is completing iteration 1 by mid-August. Thank you very much for your attention. We are happy to answer any questions you may have.